All right. Now, I said at the last video, hey, what happens if we revolve it around a different line? Well, that's exactly what we're going to start this video with. We're actually just going to do almost the same exact problem as example 2, but let's revolve it around a different line. So again, we have the same function. Kind of looks like that sideways square root function. We have the point 4, comma 4, and we're integrating, looking at this region, from 0 up to 4. But now instead of revolving about the x-axis, what happens if we revolve about the line y equals -1? What's changing and what's staying the same here? Okay, so this is example 2 plus. I don't know. Example 2 alternated. So what's changing about the shell method? Let's visualize again. What's happening with the shell method? So if we're revolving it about the x-axis, or something parallel to the x-axis, it's going to be in terms of y. We're looking at these little rectangles. Wait, I wanted to make a bigger rectangle than that. These little rectangles. Now, instead of revolving around this axis, now we're revolving about, revolving like this. Okay, so what's changing and what's staying the same? If we look at this shell, which again goes all the way around, really hard to draw this as a picture, but we have these sideways shells now. Well, the height of the shell is the same, right? If we stretch this all out, the height of this shell is still just the function value, no? Height of the shell unchanged. Height of the shell is still g of y. But what is changed is the radius. Remember, this was 2 pi times the radius. Well, the radius now is no longer the y value, right? The y value represents this distance. Well, what's the radius now? Well, it's the old y value. And then we have to go a little bit more. So this is going to be 2 pi times the old y value plus another one. And that's all that changes. It's going to be the same integral, almost, but now the radius is changing. So for these sorts of problems, this is how you'll set it up. It's going to be the same, very similar volume. The y value is still starting at 0. The y value is still ending at 4. We still have a 2 pi in front. But now, it's not y times g of y. It's y plus 1 times g of y. Like so. Now you can either distribute this or do a u substitution. No, don't do a u substitution here. That won't be good. And that's all that there is to this problem. All right. I'm not going to do this integral out because it's very, very similar to the one we just did, but I want to introduce this method. I want to do another problem. Example, I'm messing up my numbering system. I wasn't going to do it this way, but I want to. Let's call it example 3. All right, set up an integral for the volume. I'm getting lazy. I just want to give you more practice. All right, let's say that I want you to revolve something about the line. Ooh, I'm flying by the seat of my pants here. The line x equals -2. We're revolving something around that. And let's just look at let's see, I'll have it in terms of x. Let's just do square root of x. And then from 0 to 4. Kind of a similar problem, I guess. So this is our region. We're rotating it about this axis. How are things going to be the same and how are they going to change? Well, remember, we just have these shells. But now we're rotating it around, a much bigger radius. Okay, we got this sort of shell shape. And it goes on the bottom. I'm not going to try to draw it again. So it's going to be very similar to before, right? But a little different. So just like before, if you'd like, you can mark out this rectangle. The height of this rectangle is still f of x, but our radius is different now. The base is still the diameter, which is 2 pi. But now it's not just the x coordinate, right? X coordinate would only give us this distance for the radius, but we need the whole distance for the radius. It's going to be x, and then go an extra 2 units after this. So the volume will be the 2 pi times the integral. We're using x because, again, shell method is that if we're revolving around the y-axis or something parallel to the y-axis, we use x's. If we revolve around the x-axis, we use y's. So it's the shell method here, revolving around something parallel to the y-axis. So we're going to use x's. Smallest x is 0. The biggest x is 4. And then we'll have an x plus 2 here instead of an x. So no matter what line you do, it's almost the same formula. You just have to add a little bit to that radius that we're using. And again, we should fill in what our f of x is. F of x is the square root of x. And again, you could distribute the x plus 2, write things with rational exponents, and solve it this way. That's all there is for this video. So all that's changing, if you're revolving around a different line, is this guy, because your radius is getting bigger. Let me know if you have any questions, and good luck.